Hello friends, welcome back to my channel Engineering Mathematics DJ Ganit. From last few lectures we are discussing questions on chi-square goodness of fit test. In this lecture also we will discuss this question which was asked in GTU Summer 2020 exam. First we understand what is this question about. The manager of a theatre complex with 4 theatres wanted to see whether there was a difference in popularity of the 4 movies currently showing for Saturday afternoon with the following results: 86, 77, 84 and 81 customers viewed movies number 1, 2, 3 and 4 respectively. That means they have given the sample data in which 86 customers viewed movie number 1 or movie which is running in first theater. Similarly, 77 customers viewed movie number 2, 84 customers viewed movie number 3 and 81 customers viewed movie number 4. So these are the number of customers who viewed these 4 movies which are running in 4 theaters of that manager. And here the question is, complete the test to see whether there is a difference at the 5% level of significance in the popularity of these 4 movies. So the manager wants to see whether there is any difference in the popularities of the 4 movies, and for that he has this data in which they have taken customers who have seen or who have viewed movies number 1, 2, 3 and 4 respectively. So this sample data, from this sample data we have to test whether there is a difference in the popularity of the 4 movies. So here also we will apply chi-square goodness of fit test, and the null hypothesis will be that there is no difference in the popularity of 4 movies. That means the 4 movies are equally popular. This we will consider as null hypothesis. And alternative hypothesis is there is a difference in the popularity of 4 movies, and level of significance is given as 5%, that is alpha is 0.05. And here we assume that null hypothesis is correct. That means there is no difference in the popularity of 4 movies. Now it is clear that if there is no difference in the popularity of 4 movies, then the number of customers who viewed those 4 movies must be equal. That means we will find out the expected frequencies assuming that null hypothesis is correct. So for that we have to first find out the total number of customers in this sample, and if you make the total of these 4 numbers, it becomes 328. So the number of customers in the sample are 328, and we want to test the null hypothesis that there is no difference in the popularity of 4 movies. So we start by assuming the null hypothesis. We assume that the null hypothesis is correct, and if null hypothesis is correct, that means if there is no difference in the popularity of 4 movies, that means all the 4 movies are equally popular, or we can say that the number of customers who viewed each movie must be equal. That means we have to find out, we will divide 328 by 4 to find out the expected number of customers who viewed each movie, and if you take this division it becomes 82. So this 82 will be the number of customers who viewed each movie. 82 customers viewed movie number 1, 82 customers viewed movie number 2, and 82 customers viewed movie number 3, and 82 customers viewed movie number 4. So if this number is equal that means the 4 movies are equally popular. So we will assume that null hypothesis is correct, that is there is no difference in the popularity of 4 movies. Therefore, the expected number of customers for each movie will be 82, and we are given observed data or observed frequency of customers who viewed movie number 1, 2, 3 and 4. So this we will be considered as observed frequencies, and expected frequency for each movie will be same, and it will be 82. Now once we determine expected frequencies, then rest of the things are easy. We have to recall the formula for test statistic. It is given by chi-square equal to sigma observed minus expected frequencies whole square divided by expected frequency. So we will calculate this value of test statistic, and then we will find out critical value of chi-square at 0.05 level of significance with number of degrees of freedom. Here degrees of freedom is given by this formula. Degrees of freedom for this goodness of fit test equal to k minus p minus 1. K means number of categories. Here there are 4 movies, so there are 4 categories. Small p means if we are estimating any population parameter using sample data, then the number of parameters estimated using sample data is denoted by small p. Here we are not estimating any population parameter, that is p is 0, and 4 minus 1, that is 3. So we will find out chi-square critical value at 0.05 level of significance and degrees of freedom equal to 3, and then we will compare this calculated value of chi-square with this critical value. I have written all these things systematically. Whenever we are answering the question, we should write all these things systematically. We start with the null hypothesis. Null hypothesis is that there is no difference in popularity of 4 movies, and alternative hypothesis is negative statement of this null hypothesis, that is there is a difference in the popularity of 4 movies, and we assume that H0 is true. Whenever we are applying hypothesis testing, we are testing the null hypothesis. So we start by assuming that null hypothesis is true, and then we test that assumption, and level of significance here given is 0.05. Now if null hypothesis is true, that is if there is no difference in the popularity of 4 movies, then the number of customers who viewed movies 1, 2, 3, 4 must be equal, and total number of customers in given sample is 328. Therefore, if null hypothesis is true, then the number of customers who viewed each of the 4 movies is obtained by dividing this total number of customers by 4, and that is 82. That is the expected number of customers for each movie equal to 82. And here I have written observed and expected number of customers. This first column corresponds to movie number, and we can see there are 4 movies, so we have 4 categories. That means value of small k is 4. These are the observed number of customers who viewed movie 1, 2, 3 and 4, and these are the expected number of customers, which are all equal. Now we will find out all these things for each category. Difference between observed and expected frequencies, square of the difference divided by expected frequency. This we will do for each of these 4 categories to find out the value of test statistic. Test statistic is chi-square equal to sigma O minus E whole square divided by E. For first cell 86 minus 82 whole square divided by 82. For second case, second cell, observed frequency is 77. This remains same. Similarly here 84 and 81. Expected frequency is same for each category or each cell. and we can see there is 82 common in the denominator, so that we can take outside, and here 86 minus 82, that is 4, square of 4 is 16. Similarly, this difference is 5, so we have 5 square 25. This difference is 2, square of 2 is 4. Here we have square of negative 1, which is 1, and this turns out to be 46 divided by 82, that is 0.561. This is the calculated value of test statistic. Now next step is to decide the chi-square critical value, and for that we can roughly sketch this chi-square probability density curve. It is not necessary to sketch this curve every time. I am sketching just for understanding. We are familiar with the shape of chi-square distribution or chi-square probability curve. It has a right tail, it has a longer right tail, it is asymmetric, and suppose this point is our chi-square critical value, chi-square at 0.05 level of significance, then this area is 0.05. Minimum value is 0. On horizontal axis, chi-square values are there, and the number of degrees of freedom equal to k minus p minus 1. There are 4 categories. Value of p is 0, minus 1, that is degrees of freedom is 3. So we have to use chi-square table to obtain this critical value for alpha equal to 0.05 and degrees of freedom equal to 3. So let's go for this chi-square table. We have to search for alpha equal to 0.05 and number of degrees of freedom are 3. That is, we have to take intersection of this row and this column, and intersecting point is required critical value for this test. So let me remove these two rows now, and we can see chi-square critical value at 0.05 level of significance with 3 degrees of freedom is 7.815. So that we will write here, this number is 7.815. Now we compare calculated value of test statistic with this value. Calculated value of test statistic is 0.561. So you can see 0.561 might be somewhere here. This is the calculated value of test statistic. And we know that if we are considering area to the right of this critical value, then that region is rejection region, and area to the left of this point is non-rejection region. This is non-rejection region, and it is obvious that calculated value of test statistic is in non-rejection region, or we can write that value of chi-square, which is 0.561, is strictly less than chi-square critical value at 0.05 level of significance and 3 degrees of freedom, which is 7.815. This means we fail to reject the null hypothesis. And what is null hypothesis? The null hypothesis is that there is no difference in popularity of 4 movies. So we can say that the sample data provides sufficient evidence to fail to reject the null hypothesis, or we can say that from sample data we can conclude that there is no difference in popularity of 4 movies at 0.05 level of significance. The decision is we have calculated value of test statistic is less than this critical value, and therefore we fail to reject the null hypothesis. That means we fail to reject this statement that there is no difference in the popularity of 4 movies. So in this way we can apply goodness of fit test to this type of real life problems also. So this is very important test for hypothesis testing domain. So I hope you are familiar with goodness of fit test now. In the next lecture we will start with chi-square test of independence of attributes. Thanks for watching.